and the new options, the new features in Service Pack 2014 version, Service Pack 2. The main development we concentrate in this version to make the 2014 version more stable and faster. That's mean if you will install and start working with Service Pack 2, you will see a big difference in stability and in speed. But beside the speed and stability, we also implement some new requests, and those are the user requests, customer requests. For example, we'll start with offset types in face turning. We add the option Z offset. In previous versions we have only absolute offset for face turning, and we didn't output any value for cycles. When we work with cycles, if the customer want to work with cycles, we didn't have an option to output the rough offset Z for G74 or G75 turning cycles. Now in this option we add, as the standard, as we work in turning cycles, we add also for phase turning. The next option, next feature, next change that we have in last service pack is the lead in. That is working also in rough operation today, and in previous versions it didn't work if it was not be in the software. So in roughing operation we have the lead in and lead out option, and the auto lead in and lead out in finish operations is cancelled. That means the user needs always to use and lead in and lead out. It's not automatic added now, and the reason is we want to make it the same as our milling module. And in milling, if you don't add any lead in, lead out, you don't have it. The same for turning. But even if you don't define any lead in or lead out, we don't crash into the material. We still have a small distance when we approach the toolpath, and it's calculated automatic by the rest material and the shape of the toolpath. Interpolation for distance. This option was implemented by customer's request, and to solve the problem of long chips that they are going they are going to be catch by the spindle, by the jaws, and around the tool. It makes some problems. So when we have long toolpaths, we can split today the toolpath into the small lines, and the tool will make a stop, a small stop, a very short stop in every point that you see, and the chip will be broke. We break the chips. That's the option, new option, interpolation for distance, and this we split the line with the amount, with the value that you define here in equal steps. So if you have a toolpath with a line 100 millimeters, you split it to 5. So every time we are going to Z -5, -10, -15, -20, and every time we stop and break the chip. A new option is we can use in turn drill milling tools like end mill, bull nose, and ball nose mill. Before that we didn't have this option. We can select only, was selected only the drill type like reamer, tap drill, spot drill, all that you see here. Today also those tools, milling tools, are available to be selected on a turn drill operation. Machining. I think we talked about this in the past, maybe in a previous version, but the Toolpath was improved today, and I will explain you how the cutting angles and what is the difference working with step down and cutting angle. We will have an example of machining also internal and also with negative X output. This is also a new option that we put on technology. You have tools and different situations when you need the toolpath on negative side of the part and not always on the positive. So a small checkbox, a suitable tool, and you will get the correct toolpath on a negative side. Those are the new features for Service Spec 2. We also will talk about a little bit, as a reminder, the approach and retract points and how to use it. So let's start with the first one, is the face operation. I have a simple part here where can I demonstrate you and present those new options. Select the standard tool and get the face operation. The difference here, the new option, is when we use a cycle with rapid or without rapid. Before that we have only the absolute. That means SolidCAM, the software, will create offset of the geometry and generate the toolpath based on this offset geometry. Now, when we work with the cycle, the users want to use the U and W letters in the cycle to change manually in the program on the controller, and not to get back to the software and generate a new G-code, change the offset and generate the new G-code. They want the option to change the offset in the cycle. So for this we add this new type of offset Z, and now we get in the G-code as we see in the picture, turning rough offset 0.5 here with absolute. SolidCAM will generate the offset, so you will not get any offset. That's what related to the face operation, new offset type. Here I define a rough operation with the same tool, and the geometry is external. Start from here to the end of the part, and link. Let's see the difference without lead-in. Save and calculate. Let's see the toolpath. On each step we automatically add the safety distance 2 millimeters on the toolpath, but on the last step here we can add today. It's a rough operation, only a rough without finish. Here we can add lead-in option. Now Even if you don't use the lead in, the tool will not crash in on the material. Simulate. Let's see the simulation. I will not use the solid verification. Go. Okay. I miss this step, so we are going again. I didn't stop at the right time. Now, here you see this last step is without lead in, but we still have a small distance between the material and the tool that is automatically added. So even without lead in, we don't crash into the material, but when we add, say, 3 millimeters, tangent extension, save and calculate. Now you see here the lead in a rough operation. So it's available only for the last step. Here also we can I can present you how the interpolation for distance is used. We don't see in the simulation how the toolpath is splitted, but we get it in the G-code. From here, let's see the same diameter, 15 here we have a long line, long straight line on the same diameter, but we stop with Z position at -2.8, -7.7 every 5 millimeters. It's not exactly 5. We divide this toolpath from start to end in steps, equal steps, up to 5 millimeter, no more, no bigger than 5, but the steps are equal. So it's like 4.8 millimeters. And 17.4, 22.3. Now, in the G-code, to achieve this this stop and chip breaker, we need to change the post and to add maybe a model exact stop command, like in the start of this toolpath. Here, after this rapid move, here we start with the line. So before, we need to add in the post output of G61, for example. That's the model command for exact stop, or each line and G64 go back to G64 at the end of this line. So this command, the exact stop, will stop every point, will make a small stop. It's reducing the feed to 0 and continue again, not taking in account look ahead and all those smart functions to make the toolpath smoother. So this is one option, or the second is to use non-model option for exact stop, G09 every time that you bring the move, G09, because it's not modal, it's not remain active. So that's in order to use this new option, small additional change in post must be done. Okay, now let's go to see the lead in the finish operation. I make a different operation here, a separate operation for the finish. And first we'll see the toolpath, save and calculate without lead in. Here is the toolpath without lead in. Also, in this situation, we don't crash into the material. We have a small safety distance calculated depend on angle, shape of the geometry, and width, lead in. You can see directly the Toolpath, the extension at start of the Toolpath is added here. Now you can use also arc, for example. Let's see, 6 millimeters on 30 degrees, and you get the extension, the lead in, and start of the job. But is not the difference in this version is not added automatically by the software. The Toolpath we start without any lead in. We are going to the next option where I said that we can use any milling tool as milling or bullnose or ball nose. So here I select a ball nose tool, and in a turn drill operation. Just for example, I don't know how if it's correct technological to work like this, but there are cases when you want to use a different tool than drill and reamer or boring bar. Select, change tool type to bull nose 13 with 5 millimeters corner radius, and I just need to change here 5, save and simulate. That's also a new feature. We are reaching the point to show you the iMachining. iMachining was added to the list of turning operations, iMachining on turning, and it can work only with a tool, with a grooving tool, tool type grooving with a round insert. I mean, not square, round, because it's work with the same logic, with the same Toolpath algorithm like the iMachining for milling, depend on angles, cutting angles or step down. And the geometry is, I select this geometry here, and the tool, the grooving tool. In the technology we have two options: step down, let's say 0.5 it's minimum and 1.5 is maximum step down. Again, depend on geometry shape, we'll get different step downs in Toolpath. And direction can be one way or zigzag. Simulate. Let's use the solid verification. Also, this in HostCAD is the new feature. It's not new in SP in ServicePack 2, but it's new in 2014 version. You can use solid verification in HostCAD. Also, you can see the tool, the 3D tool, and the holder if you define a holder. So we don't have, but let's define together. We have this grooving tool and holder. I'm going to select not a milling, I'm going to turning. In 2014 also in STL holder database we can split to define folders and to save milling and turning holders however we want, and to rename the folders to organize our database more easier. I'm going to select an HSK. Yeah, that's good for me, I think. Left and rotate around Y. Now I should select a right because it's a right tool. HSK. R. Okay. And rotate around X. Now I get the holder. And let's see here. Save and calculate tool. Simulate. Now, in HostCAD, we can see also STL holders today and solid verification. You can show or not show. Now, difference between the step down and angle. When we work with step down, we have a minimum and maximum. That means, let's see my talents in drawing. Don't laugh about my talents in drawing. This is the depth, and from here to here, step down cannot be greater than what we define, 1.5 millimeters that I define in operation in technology, and cannot be less than 0.5. Now let's erase drawings and let's change it to angle. Now 40 degrees minimum, 60 degrees maximum. Save. Now here we calculate in this way, then from this point up to this point we have an angle. This angle cannot be less than 40 degrees or greater than 60 degrees, what we define. Those are the cutting angles. Angle where the cutting edge between the points of edge of this tool is touching the material. So let's delete it, erase, and okay. This is about iMachining technology, and here we have a toolpath with one direction. Always will go in one direction. This is what we define here, but it's better to use zigzag, and in this way the tool will equally be used in all around on the cutting edge, not only one side. Going forward and backward. Now the same operation, the same iMachining. We have an example here with an internal grooving tool. It's an internal grooving tool with a cylindrical shank with the same options, same technology, and we can work inside the part also. We select in technology long internal, and yes, we work internal. Let's see in the turning. For the turning, this is the best simulation. Here I define two geometries in the same operation. This line and this profile. Here it's a finished surface by turn drill. So here I don't need to touch it. And is going to remove all the material also here. Zigzag technology. Okay, now also pay attention about links. When I want to enter, to bring the tool, enter inside to work here, easy for me is to use the approach and retract point. I define the diameter, X and Z position, bring the tool here, and from here, from this point, you are going to start of toolpath, and from end of toolpath, you are going to retract to this point, X first. If you can see here, the toolpath is finished here. We are going on X and Z axis to go to the retract point. And for the approach point, first we are going to Z and X direction. You have several options. You can choose the best for what is the best for you. Now the same example with internal turning eye machining operation. I will suppress this and unsuppress. It's unsuppressed. Calculate. I use the same geometry, contour 3, and here I also use the same geometry selected here on envelope, on upper envelope in the positive side of X, but I want to work on lower side, negative X. The only thing that we need to do is to select the proper tool with the insert oriented down, or if you have an option to reverse the tool if you have a spindle turret with reverse option, also you can use the same tool and reverse. But here on rotary turret, this machine is with a rotary turret, I need to define a new tool with insert in opposite direction. And in technology, just use the checkbox negative X output. Save and calculate, and let's hide the tool picture. You get the toolpath in the negative side, the same toolpath, depend on the tool, and this option is very useful on milter machines with not so many stations on turret. If you have only a rotary turret with 12 stations, it's mean a maximum of 12 tools you can mount. So in this way you can use the same internal tool here, and also you can work with this internal tool outside, or opposite. Let's see the next example. If I have an internal tool, next example for negative X, I have the internal grooving tool, and which I use to remove the material here with turning eye machining on upper in positive X. Now I can turn on external with the same tool in negative side of the part. The only thing that we need to do, I define here a turning operation, only finish, use the negative output, and we get the toolpath in the negative side. Again, the geometry is selected here in this side. We don't need to go to target and define a mirror envelope. This is what we do in the past. In order to define a geometry on X negative or to work with lower turret, yes, we need to define the envelope mirror and to get this envelope also on negative side. Today this option is not needed. It's still here if you want a sketch, but it's not needed to program the part. I did something here, I changed something. Okay. Where we was? So the geometry is on the upper side of the part, but using the negative X output we can work on lower side. Also, always use approach and retract points to define a safety point, a safety position from where the tool is going to start of toolpath and where the tool is going from end of the toolpath. Those are the options, new options that we have in 2014. As I said, I will say again, it's a very stable and a very fast version. We already start to install to our customers. They are very happy with it, and I recommend you also to download and use it. That's all for today. If you have any questions.
Thank you, Florine. I see that there are no questions today. So thank you everyone for joining us. And we have all these webinars, we upload the recording in our website. So if you miss anything, you can go into our website and click and see all the previous webinars. Thank you and have a nice rest of the week.